Hi friends, in this video we are going to verify whether the given function satisfy all the condition of the Rolle's theorem or not. Here, verify the Rolle's theorem for the given function f of x equal to sin x by e power x. So here we know that the properties of the continuous function. Here, if f is the continuous, g is the continuous, then f plus g, that is sum of two function, is continuous. Here, if f and g are continuous, here if f is the continuous and g is the continuous, then the sum of two continuous function is continuous. Here difference of two continuous function is continuous. Here product of two continuous function is continuous, and quotient of two continuous function is continuous provided g is non-zero. Here if f is the continuous, here if f is continuous, if f is continuous and g is continuous, then sum of two continuous function is continuous, subtraction of two continuous function is continuous, product of two continuous function is continuous, and quotient of two continuous function is continuous provided g is non-zero. Now here I will use this property. Here let f of x equal to, here first I will write the given information. Given f of x equal to sin x, and here I am writing e power 1 by e power x as e power, let's say, minus x is defined on closed interval 0 to pi. So here this is the given information. F of x equal to sin x into e to the power minus x. Here I am writing 1 by e power x as e power minus x is defined on the closed interval AB. Here I want to use the product of two continuous function is continuous property. So here first property of the Rolle's theorem says, check whether the given function is continuous on the closed interval AB or not. So here f of x equal to, let's say, sin of x into e power minus x. So here let's say this is my f1. So f1 of x is continuous, being a trigonometric functions are continuous, and let's say this is my f2 of x, e power minus x is continuous as an exponential function. So here product of two continuous function is continuous. So here is continuous as product of two continuous function. Therefore f of x is continuous on closed interval 0 to pi. So this is the first. So this means that first condition of the Rolle's theorem is satisfied by the given function f of x equal to sin x by e power x. Now second condition, here now we have to check whether the given function is differentiable on the open interval 0 to pi or not. Here f of x equal to sin x e power minus x. Now use the formula for derivative of product rule. So here formula for the derivative of product rule says that if f of x into g of x dash is same as derivative of function, here first function as it is derivative of g dash plus g as it is derivative of f. So here let's say this is f and this is g. So here f as it is f dash of x equal to, here first function as it is derivative of second function, that is derivative of e power minus x is e power minus x into minus 1, here plus second function as it is derivative of first function, that is derivative of sin x is cos x. So here this is equal to minus sin x e power minus x plus e power minus x into cos x. So here this is my f dash of x. So here therefore f dash of x exists for all x belongs to the open interval 0 to pi. Therefore f of x is differentiable on closed interval 0 to pi. So here second condition of the Rolle's theorem is also satisfied by the given function f of x equal to sin x by e power x. Now the third condition says that the functional value at endpoint 0 and the functional value at endpoint pi is same or not. Here f of 0 equal to, here sine of 0, here sine of 0, here I will use sine of 0 into e to the power minus 0. Sine 0 is 0, this is e to the power this is 1, so this is 0, and f of pi, this is equal to sine, here pi, sine pi e to the power minus pi, here sine pi is 0, 0 into anything is 0, therefore this is 0. This means that f of 0 is same as f of pi. Therefore functional value at end point 0 and pi is same. Therefore third condition of the Rolle's theorem is also satisfied. This means that this function, now we have to find the value of c by using f dash of c equal to 0, and we have to check whether this c belongs to the open interval 0 to pi or not. Here for now find c, so this is c by using, find c by using f dash of c equal to 0, by equating the f dash of c equal to 0. This is your f dash of x. So here f dash of x equal to minus sin x e power minus x plus e power minus x cos x equal to 0. Therefore right here replace x by c. Therefore minus sin c e power minus c plus e power minus c cos c equal to 0. Take e power minus c common, so e power minus c common here I am taking. This is minus sin c plus cos c equal to 0. So here this is never become 0. This implies that minus sin c plus cos c equal to 0. This implies that minus sin c equal to minus cos c. This implies that sin c equal to cos. This implies that cos c equal to cos c, here minus minus gets cancelled. This implies that sin c by cos c equal to 1. This implies that tan c equal to 1. Here this implies that c equal to n pi plus pi by 4, so that n belongs to the set of integer z. Now put n equal to 0 here, put n equal to 0. This implies that c equal to pi by 4. Here put n equal to 0 in this equation. So this is the sequence of number. You put n equal to 0, 1, 2, 3. Here n belongs to set of integer. You can put anything, n equal to minus 1, 2, anything. Here for n equal to 0, c equal to pi by 4, and that pi by 4 belongs to the open interval 0 to pi. That is our m. This means that therefore f of x satisfy all condition of Rolle's theorem. Hence proved. Now here you can write hence at the end. This means that your function is satisfied all the condition of the Rolle's theorem. Hence proved. So here this function satisfied the condition of the Rolle's theorem. Here f of x equal to sin x by x. That is f of x equal to, I am writing sin x e power minus x, which is defined on the closed interval 0 to pi. Write f of x, product of two continuous function is continuous. So here f of x equal to, let's say this is f1, this is f2. f1 is continuous, f2 is continuous. Product of two continuous function is continuous. Therefore f of x is continuous on the closed interval 0 to pi. Take the derivative of f of x, that is f dash of x equal to, by using the derivative of product of two function. Then f dash of x equal to this. F dash of x exists for all x belongs to this open interval AB. Therefore f of x is differentiable. Now find the functional value at 0 and pi. F of 0 is 0, f of pi is 0. Therefore f of 0 is same as f of pi. Therefore now find the value of c by using f dash of c equal to 0. F dash of x equal to this, just replace x by c. Therefore f dash of c equal to 0 implies minus sin c e power minus c plus e power minus c cos c equal to 0. Take e power minus c common, so minus sin c plus cos c equal to 0. So this is never 0. Product of two continuous function is 0. Sorry, product of two number is 0. One of them must be 0. So this is never 0. That's why this is 0. Minus sin c plus cos c equal to 0. Minus sin c equal to minus cos c. Minus minus gets cancelled. Sin c equal to cos c. Therefore sin c by cos c equal to 1. this implies tan c equal to 1, this implies that c equal to n pi plus pi by 4 such that n belongs to z. Put n equal to 0 in this sequence, in this equation. So c equal to pi by 4, that belongs to the open interval 0 to pi. This implies that f of x satisfy the all condition of the Rolle's theorem. Hence this function verify the Rolle's theorem. Thank you.